Hello, today I am going to talk about the solution of the first question that involving wave equation. A long bar is struck on the end causing a stress wave to propagate along it. The mathematical formulation of this problem is given below. Solve the problem using the Laplace transform method. So, this is the given differential equation, boundary conditions, and its initial condition. Based on this question, we know that this is the general equation of a wave equation. Since the interval involved is semi-infinite, we have to use Laplace transform in order to solve this problem. For the first step, we have to take Laplace transform on both sides of the wave equation. Then, this equation is equivalent to, by substituting the initial condition into the equation, we will only get this equation at the end. As you can see, this is the second of the differential equation. We found out that this equation involves two different roots. Thus, it forms this kind of equation or general solution. Next, by using the first boundary condition, it shows that uxt approaches 0 as x approaches infinity. So, this equation also will approach 0 as x approaches infinity. Therefore, from this equation, a will be equals to 0. Since a is equals to 0, the only equation left is... Next, we have to take another boundary condition to find the value of b. In order to substitute this boundary condition into capital UXS equation, to find the value of b, we have to transform the boundary condition by using Laplace transformation first. The Laplace transform of u0t will transform into capital U0s. While by using the hint in the question, it shows that the Laplace transform of this will be equals to 1 over s plus 1 square. Now only we can use the boundary condition in order to find b. Now, we can substitute the value of b into our previous equation. Use inverse Laplace transform to transform it back into uxt. By using inverse Laplace transform of this side, we will get again the value of ft, which is t exponent to the power of negative t. For this side, we have to look into the table of Laplace transform. From this, let's take a look at entry number 16. From this entry, we can compare that a will be equal to x over c. Then, we can just substitute into the equation to convert it back into uxt. Next, we will be having uxt in this form. By Laplace convolution theorem, we will get the final answer like this.
Question 2. Heat equation. Consider the heat equation for the temperature U of a rod of length 1. The end x equals to 0 is perfectly insulated and the end x equals to 1 is held at 0 temperature. Derive the eigenfunctions x and x equals to cos n plus 1 over 2 pi x e to the power of negative n plus 1 pi squared t, where Cn is equals to 2 over pi squared n plus 1 over 2 square. The solution is we will use uxt is equals to xx dt. Ut is equals to xt prime, ux equals to x prime t, uxx is equals to x prime prime t, and ut is equals to alpha squared usx, where alpha squared is equals to 1. Based on ut is equals to usx, we got x t prime is equals to x prime prime t. T prime over t is equals to x prime prime over x is equals to k. Let k is equals to negative lambda square. We will get t prime over t is equals to negative lambda square. X prime prime over x is equals to negative lambda square. From the formula t prime over t is equals to negative lambda squared, we will use the separable method to separate the t and the dt over dt, and then we will integrate both sides to get t is equals to e to the power of negative lambda squared t plus a. For x prime prime over x is equals to negative lambda squared, we will use the characteristic equation because the x is in the second order. And we will get the m is equals to plus minus lambda I. From the value of m, we will say that the root was imaginary. It will form x is equals to a sine lambda x plus b cos lambda x. Referring u at t is equals to x at tt, our new u at t is equals to e negative lambda squared t plus a sine lambda x plus b cos lambda x. For boundary condition u at 0 t is equals to 0, u at t is equals to e negative lambda squared t lambda a cos lambda x minus lambda b sine lambda x. So u at 0 t is equals to e negative lambda squared t lambda a cos 0 minus lambda b sine 0. Form a is equals to 0. So our new u at t is equals to e negative lambda squared t b cos lambda x. For boundary condition u1t is equals to 0, u1t is equals to negative e negative lambda squared t b cos lambda x. 0 is equals to e negative lambda squared t b cos lambda. When b is not equal to 0, cos lambda is equals to 0, and the lambda is equals to plus minus pi over 2, plus minus 3 pi over 2, plus minus 5 pi over 2, and so on. So pi n is equals to n plus 1 over 2 pi. So our new xn is cos n plus 1 over 2 pi x. B. Show that integrate 0 to 1 xn x xm t dx is equals to 1 over 2 when m is equals to n and 0 when m is not equal to n. Integrate 0 to 1 xn x xm x dx is equals to integrate 0 to 1 cos n plus 1 over 2 pi x cos m plus 1 over 2 pi x dx. Using cos alpha cos beta rule is equals to 1 over 2 cos alpha minus beta plus cos alpha plus beta, we will get 1 over 2 integrate 0 to 1 cos n plus 1 over 2 pi x minus m plus 1 over 2 pi x plus cos n plus 1 over 2 pi x plus m plus 1 over 2 pi x dx. When simplified, we will get 1 over 2, 0, 1 cos n minus m pi x plus cos n plus m pi x dx. After replacing m is not equals to n, the integration will form 0, and when m is equals to n, the integration will form 1 over 2. If the initial condition are u at 0 is equals to 1 minus x, show that the solution is u at t. For C, if the initial conditions are u at 0 is equals to 1 minus x, show that the solution is u at t is equals to summation of infinity n is equals to 0, cn cos n plus 1 over 2 pi x e to the power of negative n plus 1 over 2 pi squared t, where cn is equals to 2 over pi squared n plus 1 over 2 squared. The solution is u at t is equals to e negative lambda squared t b cos lambda x. The Sn is n plus 1 over 2 pi. So, the un at t is equals to summation of infinity n is equals to 0 e to the power of negative n plus 1 over 2 squared pi squared t bn cos n plus 1 over 2 pi x. Replacing bn with cn and substitute t with 0, we will get un at 0 is equals to summation of infinity n is equals to 0 e to the power of negative n plus 1 over 2 squared pi squared 0 cn cos n plus 1 over 2 pi x is equals to 1 minus x. Cn is equals to 2 over L. Integrate 0 to 1, 1 minus x cos n plus 1 over 2 pi x. And we will get 2 over n plus 1 over 2 squared pi squared. So it was shown that summation of infinity n is equals to 0, cn cos n plus 1 over 2 pi x e to the power of negative n plus 1 over 2 squared pi squared t, QED, where cn is equals to 2 over n plus 1 over 2 squared pi squared. That's all, thank you.